Okay, I'm going to do section 8.3 now. We're going to do hypothesis tests of the mean. Maybe. Okay, so I'll do the problem that the author does in this section. Then when we meet, I'll do some practice problems. Okay, so we're in 8.3. And for the sake of brevity, we're not going to worry about this. The only thing that changes, instead of a t value, we would use a z value. And that's not S anyway, that's a sigma. So there's a typo by the author. Okay, hypothesis test about a population mean. It's gonna look very similar to what we did. We're gonna have mu equal to something for the null hypothesis. The alternative will be mu would be less than, mu greater than, or mu not equal to, and that's given to us in the context of the problems. We know all these. The one thing is, don't forget, central limit theorem says these are the same. So I don't label this way, I use mu because it's the same thing. Same requirements we've seen before. Simple random sample. Either it's normally distributed, the population may say it in the problem, or n greater than 30, or in the case of the problem we're going to do, I'll show you what we'll do in our class. Okay, there's our test statistic. Notice it looks kind of like the one we did, where our z test was, remember it was p hat, the sample data, subtract the p, what we thought was the population. This really is the margin of error. That's the same thing there. And then over here we had p times q divided by n. Big difference here is not doing p and q, we're still using s, because we don't know and we don't think we know what the population standard deviation is. We think we know that from our null hypothesis. Okay, let's just get to our problem. And let's do some rounding here. How about, I'll go S is 1.99, that's fine. I'll go X bar is 6.83. Now, what do we got going? Adults should sleep between 7 and 9. We're going to use a test statistic, the critical value method, to test the claim that the mean amount of sleep for adults is less than 7 hours. Okay, first thing I'll do is this. Right from there, I've got my hypotheses, less than. So my null, mu is equal to 7. The alternative, mu is less than 7. Now, one thing that you should notice is n is 12. So this is not greater than 30. Doesn't say anything about normal population. So we'll test the normality. And the way we're going to do that is I made a little dot plot of our data. It's not totally out of normal. I mean, it's kind of bimodal. So when I see something like this, okay, my sample isn't the best normal distribution. So I'm not sure if when I get to my results that I'm going to be all that confident in them. So that's all I'll say. Confident in results. I would question it. just because we don't have enough N or large enough N, enough data points, and it's a little out of normal, but good enough to proceed. Okay, we've already got these. Okay, significance level 0.05. It's going to be a left tail test. I'm just going to do it. I'm going to set this up. Alpha is 0.05. I need my critical T value. So my degrees of freedom is 12 minus 1 equals 11. And notice this is a one-tail test. And it's the left tail because my H1 is mu is less than 7. So let's go find our critical T. And it's been a while since we've done that. Let's go on to our formulas. Here we go. Now, when we were doing confidence intervals, we used this a lot. Now I'm doing a one-tail test. There's my alpha. Degrees of freedom is 11. There's my T. I just ruined that. My T is 1.796. So one-tail tests up here. If you got a two-tail test, this is fine. Let's go back. 1.796. Notice it's negative though, because it's a left tail. Remember, T is 0 in the middle, just like Z. Okay, my X bar was 6.83. Standard deviation, 1.99. Now I'm going to find my test statistic, my critical value. X bar, 6.83. Subtract mu, which we think is 7. Notice that's going to be negative. That's good because we'll be in the left tail. Square root of S. Oops. S, which is 1.99 over the square root of N. N was 12. Just to make sure we got all that right. Oh boy, that's way up here. Huh, there it is. Okay, so we're okay there. Now it's calculator thing. Hang on. Sorry if I'm making you seasick, motion sick. Let's find it. I got negative 0.296. Okay, that falls here. So that's my test statistic. It's to the right. So it's not out in my critical area. So right away, I know I'm going to reject H naught. So we have to write our conclusion. Got to put the, and I know somebody's screaming. I can hear you because I can't remember what I said. I was thinking too far ahead. We failed to reject H naught. Thanks for whoever was screaming at me. So our evidence does not support that the mean hours of sleep for an adult is less than 7 hours. Okay, so again, notice I went back. I put the context in here in my conclusion. So just to reiterate everything. Okay, I read. Okay. Here's my analysis, which I really should have put this in up above just to do the whole problem. Should have said H naught, mu equals 7, H1, mu is less than 7 hours of sleep. And now I can go, okay, all this pretty much analysis, including the diagram over here. I've got my arithmetic or the math part to finish up. I go, okay, that's over there. That's in failed to reject land. Our evidence doesn't support the alternative hypothesis that the mean number of hours of sleep is less than 7. So that's the basics of doing a hypothesis test with a population mean.